right, let's take a look at some examples from section 10.2. We're asked to simplify this quantity, the fourth root of 81 r to the 8th s to the 20th power. Now there's really two ways to go about this, and I'm going to show you both ways, but the second way is really better. But let's separate these two here. One way to do this is to keep the fourth root notation and write out what this is. And this is going to be long-winded, folks. 81 is 9 times 9, and 9 is 3 times 3. So 81 is 3 times 3 times 3 times 3. And then r to the 8th is r times 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 r. I'm going to need a bigger radical. Let's see. I hope that's enough there. Then s is s to the 20th is s times 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 s. Yikes. Holy moly. Now, since we're working with a fourth root here, we can break this up and group things in groups of 4. So I have one grouping of 4 3s. I have two groupings of 4 factors of r, and 1, 2, 3. Oh, that's kind of bleeding together there. Let's fix that. 2, 3, 4, 5 groupings of s, which means that this is going to be a single 3 times an r times an r times an s times an s times an s times an s times an s, for a grand total of 3 r squared s to the 5th power. That's our answer. But there's a better way to do this. Or we can rewrite the following. The fourth root of 81 r to the 8th s to the 20th in exponent notation is everything underneath the radical, 81 r to the 8th s to the 20th raised to the 1/4 power. That is to say, that exponent is the fraction 1/4. And so that's going to allow us to then rewrite this, since this is multiplication, as 81 to the 1/4, r to the 8th to the 1/4, and s to the 20th to the 1/4 using exponential rules. Now, 81 is actually 3 to the 4th power, which means that we're going to multiply these exponents together. Let's get a different color here. Multiply. 4 times the 4th is 3 to the 1st power. We'll multiply 8 times the 4th, or 8 divided by 4 is the 2nd power. And then finally 20 divided by 4 is the 5th power, and we end up with 3r squared s to the 5th. Quite a bit faster, and without writing all of that out, we see that we get the exact same answer. So it's that shorthand exponential notation that's really going to save the day here. So let's try another one. Here's b. Let's see, this is 32 x to the 10th y to the 6th power raised to the 1/3. So again, the cubed root is the 1/3 power. And I'm going to rewrite that, one more time here, as 2 to the 5th x to the 10th y to the 6th power to the 1/3. And we're going to be able to simplify that a little bit. This is 2 to the 5th to the 1/3 power. times x to the 10th to the 1/3 power times y to the 6th to the 1/3 power. Now, before everything was whole numbers. Here, that's not the case. Let's see, 5 times a third. The best we can kind of do there is 2 to the 5/3 x to the 10/3, and oh, that last one turned out to be nice, y squared. Now, we can rewrite this as the cubed root of 2 to the 5th times the cubed root of x to the 10th, that doesn't help us out too much, times y squared. So the question is, can we simplify these any further? And the answer is yes. Instead of doing that step, let's go back here. And let's talk about what is 5/3. Well, most people would say, oh, that's a decimal. It's 1.6 bar or something like that. But, you know, when you were younger and you were first learning fractions, you might have said, well, 3 goes into 5 one time with 2 left over. So that's 1 2/3. 5/3 is 1 2/3. So what we can do is we can rewrite this as 2 to the 1 plus 2/3 power. Now again, that is to say 3 goes into 5 one time with 2 left over. Just like 3 goes into 10 for x, 3 goes into 10 3 times with 1 left over. So I can write 10/3 as 3 plus 1/3. And then, of course, we have y squared. Now, the reason it was beneficial to do that is because we have an exponential rule that says when you add the exponents, that's the same thing as multiplying the following bases. 2 to the 1st times 2 to the 2/3 times x to the 3rd times x to the 1/3 times y squared. And what I can do there is, first I'm going to bring all my whole powers out here. This is 2 to the 1st, x cubed, y squared, times, I'm going to rewrite x to the 2/3 as the cubed root of 2 squared. And I'm going to rewrite x to the 1/3 as the cubed root of x. Now, since those both have the same order on the radical, the same power on the radical 3, I can rewrite this as 2x cubed, times y squared times the cubed root of 2 squared times x. And I can finally simplify this as 2x cubed y squared times the cubed root of 4x. And that is the simplified version of this expression.